Now it's time to look at some inverse trig function expressions. I'll start with a nice easy one, cosine inverse of radical 3 over 2. And immediately I find an answer here at pi over 6, or 30 degrees. I'm going to focus solely on radian answers, so the answer that would come back is pi over 6. If for some reason you had paid a little bit more attention and realized that if you almost made a full revolution, which would have been 330 degrees, or 11 pi over 6, you would realize that you could have also had a cosine of radical 3 over 2. You could have also had that same effect if you had just gone back a little bit, specifically negative 30 degrees or negative pi over 6, and again you would have seen that this would be the answer. But there are many answers, but when it comes to a cosine inverse function, if you put in the ratio of radical 3 over 2, you're only allowed to have, there we go, I'm drawing this a little bad, one answer. And that one answer has to fall between 0 and 180 degrees. But if we're doing radians, which is our focus, it would be from 0 to pi. So as much as 330 is nice and would give you a radical 3 over 2, it's bigger than 180 degrees, so we can't use that. And although negative 30 degrees is very close, it's below 0, we can't include that, and that's why you get pi over 6 as your sole answer. Our second problem is going to be looking at sine inverse of, some difficulty here, but let's try negative radical 2 over 2. The first answer as I make my way around the circle is here at 5 pi over 4. There you go. I have that. Except here's the problem. If you remember, sine inverse's range only gives answers from negative pi over 2 to pi over 2. Well, pi over 2 stops here, so I'm not allowed to go any farther than this line, pi over 2. So the moment I pass this line, I could not get this answer of 5 pi over 4, which would also explain why I'm also not allowed to get the answer 7 pi over 4, even though this has a negative radical 2 over 2. So if I'm not allowed to go this way, let's change the color. I will have to go clockwise, and it seems that if I go clockwise, the first answer I get will be this negative radical 2 over 2. But this angle here is not 7 pi over 4. Remember, that's only if you go counterclockwise. If you go clockwise, this angle would be negative pi over 4, which is fine because negative pi over 4 does fall in between negative pi over 2 and pi over 2. And it's that same restrictions that we had before. Where's my... So there we go. I'm a little bit off. Some difficulty. Also why I can't go beyond this line as well to get back to here. So this one will never even be looked at because I'm only allowed to be on the right side. I'm only allowed to be on this side of this line here for giving back answers. So sine inverse of negative radical 2 over 2 would be negative pi over 4. So now that we're getting the hang of this, where's my pen? There we go. Should not come as a surprise that our next problem is going to kind of have us look at the same thing, which is tangent inverse of negative radical 3. And you have to realize that that's sine divided by cosine, so sine negative radical 3 over 2 minus 1/2. This would be a negative radical 3 for a slope from this line down to here. Well, this should be a good answer, but here's the problem again. Our range of answers are only allowed to go from negative pi over 2 to pi over 2. So once again, we're stopped once we get to here. We can't get to this value of negative radical 3. So as much as 2 pi over 3 would be a valid answer, it's not the answer that's going to come back in an inverse trig function. And if you can't go forwards any more than this, then you're going to have to go, let's change the color, you're going to have to go backwards, and you're going to have to go back, and so because this is slope, it would continue down to here, but this wouldn't be 5 pi over 3, that's only if it's counterclockwise. So if you're going clockwise, that would be negative pi over 3. That would give you the same tangent ratio of negative radical 3. And so I would put here negative pi over 3. Now that we've done some basic expressions, let's go for a more complicated version. How about cosine inverse of cosine of 7 pi over 6? So if I look at 7 pi over 6, I find the ratio. I get negative radical 3 over 2. So from a function box perspective, in goes cosine, into cosine I mean, is 7 pi over 6. The ratio that comes out is going to be negative radical 3 over 2. So right now I can write cosine inverse of negative radical 3 over 2. And you would like to think that since I got negative radical 3 over 2 out, I would get 7 pi over 6 to come back out again. And fortunately, if you actually do cosine inverse, you don't get that. This is not going to happen. And the reason for that is, again, is that cosine inverse has a range that goes from 0 to pi. Because it goes from 0 to pi, you get blocked right here. You never get to 7 pi over 6. So although this is what you were looking for, you are not going to find it down here. You're going to find it up here at 5 pi over 6. And so the answer that you do get out is 5 pi over 6. And there's my pen. And there's the answer. So let's look at a second problem. Sine inverse of sine of 2 pi over 3. And what you realize at 2 pi over 3 is I get a radical 3 over 2. So sine inverse of radical 3 over 2. And you would like to think that because you have radical 3 over 2, you're going to get 2 pi over 3. And if this was a cosine inverse function, it wouldn't be a big deal. But sine inverse doesn't have the same range. Its range stops at pi over 2, so you don't get to cross this line here. Actually, the range for sine falls between negative pi over 2 and pi over 2. So you don't get 2 pi over 3 out. You got to find another one that has radical 3 over 2. That happens to be at pi over 3. And so in this case, pi over 3 is your answer. So now let's go to our third and final problem here. Of these, tangent inverse of tangent of 3 pi over 4. Now, before I go any further, I'll have to remember that tangent is normally found by taking the sine, which in this case is radical 2 over 2, dividing it by negative radical 2 over 2, and that works out to be negative 1. So I am looking for an angle whose slope is negative 1. Do you think I'm going to get it at 3 pi over 4? No. Why? Because tangent inverse's range does not allow you to have an answer past negative pi over 2, just like sine. So again, as much as you want to give this answer out, you're not allowed to have this answer. The key is you have to find one that has the same slope, which looks like would be this one right here. But before you tell me it's 7 pi over 4, remember you're not allowed to go counterclockwise because you can't pass this line. So if you're not allowed to go counterclockwise, you're going to have to go clockwise, and the clockwise means, oops, that's yellow, you can't see that, or maybe it's hard to see. If you can't go counterclockwise, you're going to have to go clockwise. And so 7 pi over 4 is not the angle you're actually looking at. You're actually looking at negative pi over 4. It's the same location on the unit circle, but it's not the same angle. So my answer up here is negative pi over 4. One last way of reminding this. All the possible answers, sine inverse, cosine inverse, tangent inverse, they all can give you answers that fall in the first quadrant. This will cover any acute angle that would be perfect for a right triangle. Cosine inverse is the only one that goes into the second quadrant. So if you want an answer in the second quadrant, cosine inverse is your job. However, sine inverse and tangent inverse will give you answers in the fourth quadrant. But you can't get to the fourth quadrant going counterclockwise. You can only go clockwise, which means these are actually negative angles. So you can't look at this as 3 pi over 2, but negative pi over 2. You can't look at this as 5 pi over 3, but negative pi over 3. This would be negative pi over 4. This would be negative pi over 6 and everything in between. So, first quadrant, all three work. Second quadrant, only cosine works. Fourth quadrant, only sine inverse and tangent works. What works in the third quadrant? What angles come back there? Nobody gives you an answer that ever falls in the third quadrant.